Bloom's revised taxonomy. The cognitive constructivist learning theory came into being as a response to behaviorism. Cognitivism emphasized that the mind is an information processor and we understand concepts as a whole, not in pieces. The cognitive approach led to the conception of Bloom's taxonomy. Taxonomy refers to a form of classification. This was an instructional model proposed and named after Benjamin Bloom. Bloom did extensive research to find a method to classify the thinking behavior of the mind. Eventually, he developed a framework that became a taxonomy called as Bloom's taxonomy in 1956. As the term taxonomy suggests, Bloom tried to classify thinking into 6 cognitive levels of complexity. The lowest 3 are knowledge, comprehension, and application, while the highest 3 levels are analysis, synthesis, and evaluation. Since the taxonomy is hierarchical, each level is subsumed by the lower level. For example, a child functioning at the application level when trying to make a sentence with the word epitome should also master the spelling and pronunciation of it, which fall under the knowledge level. She or he should also be able to understand the meaning of the word that relates to the comprehension level. The level of Bloom's taxonomy are labeled in the form of uncountable nouns. Later, a new group of cognitive psychologists led by Anderson, a former student of Bloom, revised the taxonomy. The revised version consisted of the following 6 labels as shown in the pyramid below. Knowledge became remember. Comprehension became understand. Application became apply. Analysis became analyze. Synthesis became evaluate. And evaluation actually changed to create. These changes were brought about in 2001 in the Anderson-Crothall taxonomy that was a revision of the Bloom's taxonomy. Basically now, the nouns were replaced by the verbs. So from 1956 to 2001, the taxonomy became remember, understand, apply, analyze, evaluate, and create. Knowledge dimensions defined. Anderson argued that the original version consisted of nouns and was unidimensional in nature and consisted of the knowledge dimensions, that is, the kind of knowledge acquired. The newer version had action words that created a cognitive and knowledge matrix. The cognitive dimension represented the process used to learn a concept. Also, the newer version witnessed an interchange of the highest 2 levels. The updated version added the metacognitive knowledge type. This knowledge talks about how to go about solving problems and doing cognitive tasks. Factual. The basic elements learners should know to be acquainted with a discipline. Example, the phonological awareness of a word. Conceptual. The interrelationship between the basic elements within a larger domain. Example, the category to which the word belongs, its inflectional forms, and so on. Procedural. How can the knowledge of the previous levels be applied and synthesized? Metacognitive. Knowledge of cognition and one's own process of learning. It not only includes contextual knowledge, but also knowledge of the self. The advantage of the newer version is that all the components have been laid in such a manner that when the instructional task is chosen and its feasibility in classroom teaching is studied in the cognitive and knowledge matrix, the outcome can be easily traced and documented. This version makes the teacher and student assessment easier and cleaner. For instance, if you visualize a table, you have knowledge dimensions in column 1, which can be factual, conceptual, procedural, metacognitive, laid out in 4 rows below. Against these columns, there can be more columns which are of the cognitive dimensions. So imagine a table, a matrix, where the first column has the knowledge dimensions. In 4 rows below, there is factual, conceptual, procedural, and metacognitive. The next 6 columns are all under the cognitive dimensions of remember, understand, apply, analyze, evaluate, and create. So if you had to understand the knowledge dimension of something that is factual in nature, to remember, one would list some things. To understand, one would summarize. To apply, one would classify. To analyze, one would order or sequence the information. In evaluate, to understand, to showcase one's knowledge of the factual dimension, one would look at ranking. And in create, we could combine facts. Under the conceptual knowledge dimension, in order to remember, one would describe. To showcase understanding, one would interpret. To showcase application, one would experiment. To analyze, one may explain. To evaluate, one may assess. To create, one may plan. For the procedural knowledge, to remember, one may tabulate. To showcase understanding, one may predict. To apply, one may calculate. To showcase analysis, one may differentiate. To evaluate, one may conclude. And to create, one may compose. To showcase one's metacognitive dimension of knowledge, to remember, one may use appropriately. To understand, one may execute. To apply, one may construct. To analyze, one may achieve. To evaluate, one may take action. To create, one may actualize. And you see that this table kind of grid gives you a grid to understand that all the cognitive dimensions can be applied to each of the knowledge dimensions. The subsequent table summarizes the Bloom's Revised Taxonomy, or BRT as it is known. We need to understand how this grid is useful for us as teachers. That each intersecting block consists of a verb that tries to explain the cognitive process dimension of that stage. 1A, or the factual element, is the block that explains the convergence of 2 components of the cognitive and the knowledge dimensions. The action word lists indicates that the learner shows an understanding of the factual knowledge and the mind active. This grid summarizes the Bloom's Revised Taxonomy, or BRT as it is known. Let us understand how this grid is useful for us as teachers. The taxonomy, as the table suggests, that each intersecting block consists of a verb that tries to explain the cognitive process dimension of that stage. So the first block of factual knowledge dimension explains the convergence of 2 components of the cognitive and the knowledge dimension. The action word list indicates that the learner shows an understanding of the factual knowledge and the mind activates at the cognitive level of remembering any text. For instance, 5C is the block which refers to the intersection of evaluative and procedural components of the 2 dimensions of the taxonomy. Right? For instance, we could look at the word conclude and then understand that it does both evaluate, and what it does is it explains to us what is the procedural knowledge acquired. Let us check in a reading text activity how the various dimensions of learning intersect. Activity. There is a passage on nutty trivia. Let's read the passage. For centuries, hand-ground peanuts were made into a paste and eaten by the Peruvian Indians and African tribes. Ambrose Staub, a St. Louis doctor, invented a peanut mill in 1903 to make butter for elderly patients with weak teeth. Eventually, the idea caught on, and these days peanut butter is a popular and nutritious staple in the American diet. However, no one is quite certain who the first person was to combine peanut butter with jelly to make the now famous peanut butter and jelly sandwich. The first question on this passage could be, who invented the peanut mill and when? The answer would be Ambrose Staub in 1903. This indicates the first level of the taxonomy of remembering the factual knowledge. This question may be called a factual question that activates the remembering level, and the learner lists the name and the year when the peanut mill was invented. Question 2. What makes you conclude that peanut butter is a popular staple of the Americans? Answer. The invention of the peanut mill, its manufacture in abundance, and the high nutritive value of peanut butter make it a popular staple in America. What do you think this indicates of the taxonomy? Well, in this question, the learner at the procedural level of knowledge tries to find out the reasons for which the peanut is a staple. Example, its growth and nutritive value, and provides a concluding remark. This taxonomy acts as a very important pedagogical tool for teachers to design their lesson plans. Moreover, assessment questions can be framed based on the cognitive and knowledge domain. Let us discuss a sample activity that will exploit the cognitive and knowledge dimensions of the new version of the Bloom's taxonomy. What you can do is preview the previous passage, read the table which enlists the two-dimensional matrix of the BRT. Notice the words in bold that indicate every question is systematically worded following the Anderson's BRT model. So let's look at the passage. The passage is titled, Olive Oil Works as a Natural Painkiller. It's not just price that makes extra virgin olive oil different from other oils. Now scientists have discovered that it contains a chemical compound that acts similarly to the painkiller ibuprofen. Paul Breslin from the Monell Chemical Senses Center in Philadelphia and colleagues describe in Nature how they isolated a compound called oleocanthal from the extra virgin olive oil. Pouring 50 grams of the best olive oil on your food each day is equivalent to about 10% of the average ibuprofen dose. So what can the factual questions be in terms of the factual knowledge domain? Let's look at the cognitive domains of remember. For remember, we can ask a question such as, what is the chemical compound in olive oil that acts as a painkiller? To showcase our understanding of the factual knowledge, we can ask a question such as, what can you infer about the price of olive oil? To showcase the application of factual knowledge, we can ask a question such as, from your understanding of the text, identify any one reason why olive oil is better than other edible oils. To showcase evaluate function of factual knowledge, we could pose the question as, what inference can you make about Paul Breslin? To showcase our analysis of factual questions or knowledge, we can pose a question such as, what is your opinion about the advantage of using olive oil over other oils? And to finally indicate and showcase our creative understanding of the factual knowledge and our creative cognitive dimension of the factual knowledge domain, we can state an activity such as develop a pictographic chart to show why olive oil should be included in our daily cooking. Say we want to test conceptual knowledge domain or based on the same passage. We can have questions for remember, such as describe why olive oil can be a healthy substitute for the cooking oil we use every day. Understand concept of the cognitive domain can be tested for conceptual as, what was Breslin's interpretation of the use of olive oil? to showcase application or apply cognitive domain for the conceptual knowledge domain, our question could be, what experimentation was done by Breslin to examine how students will evaluate the conceptual knowledge domain? We can ask them to explain in your own words, what does the text mean? To understand how students analyze the conceptual knowledge, we can ask them, do you agree with the statement that extra virgin olive oil is different from other oils? If so, how? To enable them to create something of the conceptual knowledge domain, we can ask them to discuss the advantages of olive oil. To test the procedural knowledge based on the passage on extra virgin olive oil, we can ask them to remember. And for remember, our questions can be, list any 3 words from the text and write the words that mean the opposite. For example, equivalent, distinctive. To test their understanding of the procedural knowledge, we can ask them to paraphrase the text in about 70 to 80 words. To test their application of procedural knowledge, we can ask them to make a sentence with the word isolate. To make them evaluate procedural knowledge, we could ask them to differentiate between olive oil and other oils. To make them analyze procedural knowledge, we can ask them to write a conclusion of the passage. To enable them to create procedural knowledge, we can ask them, imagine you are a dietitian. A patient comes with health problems like diabetes, calcium, and D3 deficiency. Compose a dialogue between the two of you where you tell him the benefits of olive oil. Then there is the metacognitive knowledge domain. To test students on remembering cognitive function of the metacognitive knowledge domain, we can ask them to use the word painkiller appropriately in a sentence. We could ask them if they have understood the metacognition by framing a question such as, if you are asked to execute an awareness drive about switching to olive oil, how will you do so? To get them to understand how to apply the metacognitive knowledge, we will ask them questions such as, will too much consumption of olive oil lead to any side effects? To enable them to evaluate their metacognitive knowledge, we can ask them questions such as, what do you think was the achievement of the scientist Mr. Breslin from the study? To enable them to analyze metacognitive knowledge based on the passage, we can ask them a question such as, justify your stance on the use of olive oil as a healthy substitute for edible oil. Thus, these cognitive domains included in the taxonomies form the basis of the constructivist approach to learning. The taxonomies can be used as a reference point in planning classroom instruction and designing different activities and tasks to achieve certain objectives. Different language learning tasks can be designed to achieve specific learning outcomes that represent the various levels of cognition.